We are living in this, golden age of AI, right? Its potential to completely change science feels, well, almost limitless. But here's a thought. What if AI didn't just help scientists? What if it actually led the way?
I mean, that's the big one, right? The ultimate question. Can an AI really make a discovery that no human has ever made before? Can it step outside of everything it's been taught and find something completely, fundamentally new? All right, let's really get into this.
So we're talking about AI's next great challenge. And it's a big one. How do we get from an AI that's just an amazing problem solver to an AI that's a true discoverer? That jump? That is the next great hurdle for, well, pretty much everyone in the field. Look, we all know AI can do incredible things. It can master super complex games, it can write code, it can sift through mountains of data. But all those things have one thing in common. There's a known answer somewhere. But what happens when there is no answer key in the back of the book? That is the real frontier, moving beyond just solving old problems to making brand new discoveries.
Okay, so to really get why this is so tough, you have to look at how we've been grading AI's progress. And well, here's the thing. The tests are getting way too easy.
So you take a look at the standard math tests for AI, things like the Math Dataset or GSM-8K. The top models, they're basically acing them. We're talking scores over 90%. In the field, they call this saturation. And it's a huge problem because think about it. If everybody gets an A+, the test doesn't really tell you anything anymore, does it? You can't tell which model is actually reasoning and which one is just really, really good at memorizing the textbook.
And this gets to the fundamental flaw, the big catch. Solving problems that already have answers isn't the same as making a new discovery, not even close. See, these tests are full of problems that have been solved for years, and the solutions are all over the internet. You know, the same internet these AIs were trained on. It's literally like giving a student an open book test where the book is, well, all of human knowledge. It's not a real test of discovery.
So that's the problem. And this is where a brand new project called HorizonMath enters the picture. It's been designed from the ground up to be a totally new kind of test, one that, in theory, can't be cheated. So what's the secret sauce here? Well, it's this really clever idea called the generator-verifier gap. It's pretty simple when you break it down. Some problems are just ridiculously hard to solve, but once you have a potential answer, it's super easy to check if it's right. Think about it like this. Trying to write the next great symphony is, basically impossible. But if you hear a masterpiece, you can recognize it. That's the gap. And HorizonMath is built entirely around exploiting that idea.
And the way they do it is built on 4 core principles. It's pretty genius, actually. First, and this is the big one, it only uses unsolved problems, so there's absolutely no chance the answers are in the training data. Second, it demands a concrete answer, a number, a formula, something specific, no wishy-washy essays. Third, checking the answer is totally automated, so it's super fast and completely objective. And finally, number 4, these aren't just some random brain teasers. These are scientifically important problems pulled straight from current, active research.
And believe me, this isn't just a test on one little corner of math. HorizonMath is a true gauntlet. It pulls these unsolved problems from all over the place. We're talking number theory, discrete geometry, even continuum physics. It is a massive, comprehensive stress test designed to push these AIs to their absolute limits. Okay, so the stage is set. We have this new, uncheatable benchmark. Let's get to the main event. What happened when the world's best AIs were put up against this thing? All right, so how did they do? The results are, well, they're pretty humbling, to say the least. On these unsolved problems from HorizonMath, top models like Claude Opus and Gemini Pro, they scored a 0, a flat 0. GPT 5.4 Pro did a tiny bit better, solving about 2%. Just think about that contrast for a second. We went from 90+% on the old test to basically 0. This just shows that HorizonMath is playing in a whole different league. And hey, just to be fair, what's the score for a human expert on these problems without any help? Yeah, it's also 0. These aren't just hard problems. These are problems at the absolute frontier of what we know, unsolved by anyone. So you've got humans stumped, you've got most of the best AI stumped. The question is, could any of them do it? Could an AI actually achieve something that no human has yet? And amazingly, the answer seems to be yes. In that sea of zeros, one model actually found something, not just one thing, but 2 potential breakthroughs. You heard that right.
GPT 5.4 Pro came up with two solutions that look like they improve on the best published results we have for two different unsolved problems. This isn't just solving a test anymore. This could be a real, honest-to-goodness contribution to mathematics driven by AI.
So let's look at the first one. It's in a field called Ramsey theory. The super simple way to think about it is it's the math of finding guaranteed patterns in chaos. Like, how big does a group have to be before you're guaranteed to find two people who know each other? The specific problem was about something called diagonal Ramsey numbers. The goal is to find a better limit, a tighter bound. And get this, GPT 5.4 Pro found a new way to do it that improved the old record by almost 3%. Now that might not sound like a lot, but in a field like this where progress comes in these tiny hard-fought inches, a 3% jump is a really big deal.
Okay, breakthrough number 2. This one is a wild geometry puzzle called the Fin Triangle Kakea problem. Basically, imagine you have a tiny needle and you want to spin it around a full 360 degrees, but you have to do it in the smallest possible area. This is a special version of that puzzle, and it's connected to all sorts of other fields. And here, GPT 5.4 Pro's solution was able to beat the previous record, which, by the way, was held by another AI, Google DeepMind's AlphaEvolve. It found a smarter arrangement that shrunk the area by almost 5%.
So, okay, two potential new discoveries from an AI. This is pretty huge. So where do we go from here? What does all this actually mean?
Now, we have to put a few important caveats on this. It's really important to be clear. What the AI produced are what you'd call strong conjectures. They aren't formal, buttoned-up, ironclad proofs. Not yet. They still need to be checked and double-checked by human experts. But, and this is the really exciting part, this shows that an AI is capable of taking that very first, super important step in any discovery, coming up with a brand new idea that we can actually go and test.
You know, the authors of the HorizonMath paper said it perfectly. They wrote, "New theorems must first begin with accurate conjectures." And that is the whole ballgame right there. Just being able to generate a good guess, a plausible, testable idea that's better than anything a human has come up with before, that is a huge part of the scientific process. It's the spark that starts the fire.
And all of this leaves us with one heck of a question to think about. What HorizonMath has just shown us is that AI is standing right on the edge of real, genuine mathematical discovery. So, the next time a huge scientific breakthrough happens, who's going to find it first? A human or an AI?
I'd say the race is officially on.